All right. Hello. It's Monday. I think there are, what? Like less than, how many weeks? 3.5 weeks left for assignment 3? Is that right? No. Yeah. Yeah, that's right. Because there's 3 weeks. The final exam is 3 weeks from today, right? And here we are reviewing the midterm. That happens. I did think about that, but I thought it was worth going through the midterm because the midterm is a lot like the final exam in this class. And several of the midterm questions should give you some ideas about what you'll find on the final exam. And so I wanted to walk through a little bit, particularly got some great feedback from some of the TAs who did the grading as far as sort of things that people struggled with or some problems that you guys might want to think about more carefully when you actually take the final. All right, so overall, I don't know how well you guys can see this. Of the 150 people that took the exam, the median and average score were both about 35. I don't know what the distribution looks like, but it could be somewhat normal given those numbers. And the standard deviation, it was 6.66. Didn't make that number up. I don't know if that's a bad omen for you guys or what. The mark of the beast was yours. Maybe it goes out to another 6, actually. I should have taken it out to 3 decimal places. So I thought people did pretty well. Actually, there was a good cluster of pretty high scores. We had a number, did anyone get a 50? I don't think anyone did. We had a couple of 49s, I think, and some 48s, 47s. So we had a good group of high scores. All right, so I'm not going to talk about the multiple choice. Does anyone care? These are pretty obvious. I don't think there's any real ambiguity here about, does anyone have any questions about these? I didn't mean to like minimize the multiple choice questions. It cleared 10 points. Matt.
Can you explain
Okay, so let's see here. Number 2. How can these two cause an exception? Well, LW should be pretty simple. How could LW cause an exception? If one of the operands, right? So LW is going to load a word of memory into a register, right? And so if the operand from LW is not mapped in the TLB, that'll cause an exception. How can add IU cause an exception? Yeah.
Cause an overflow exception?
I don't even know if that's true, but that's possible. That's not the exception I had in mind. Yeah.
If the register you're trying to put it into is 0.
No, I mean, okay, so my guess is there probably are some ways that IDIU can actually generate an exception. That's not exactly what I had in mind. I had something else in mind. How could trying to execute this instruction generate an exception? If this instruction is on a page of memory that is not mapped in the TLB. Right, so that's what we had in mind, right? Any instruction can generate an exception because the process of fetching the instruction can generate a TLB fault. Yeah. Does that make sense? Maybe a little bit of it. Well, I'm not going to call that a trick question, but I mean, clearly the two of the other ones can generate exceptions, right? Syscall exists to generate exceptions, right? And LW clearly can generate an exception because it's accessing memory. So that maybe was enough of a hint to get you to all of them, right? Any other questions about the multiple choice? All right, so let's talk about the more interesting stuff. The first short answer question, maybe we should sort of go in order of the one that people, let me start with the ones that people avoided. There was one, oh no, hold on. There was one that nobody answered. There we go, yeah. The question about NUMA memory seemed to frighten people. But the thing was, it wasn't actually a very hard question if you just read it and sort of filtered through the terminology, right? Maybe it was because it was long, I don't know. Is it longer than the other questions? Oh, okay, it's longer than that one. It's longer than that one.
Ain't nobody got time.
It's long, yeah, exactly. Right. Maybe we need to do some speed reading lessons here. It's longer than this one. Okay, so maybe it's because it was the only 2-paragraph short answer question, right? But if you could drag yourself through the 2 paragraphs of beautifully written prose describing NUMA memory, you ended up with an answer that wasn't actually that hard. I mean, again, the median score was a 4.5, right? So most people that managed to, to actually work their way through this question got it. The idea was if I have two types of memory with performance differences, I'm trying to remember what the question actually asked. I mean, so it means that where I put things in memory now has a performance implication, right? Because memory is non-uniform. So if I put a page in a part of memory that's fast, it's going to be faster to access. And if I put it in a part of memory that's slow, that's sort of obvious, right? The way we've been thinking about memory, all memory is created equal. So we've talked about memory being just faster than the disk and slower than last level caches, right? But this is asking you to think about memory that has a little bit more subtlety to it. And the simple answer we were looking for as far as a approach was just use the fast part as a cache, right? Operating systems are a series of caches. We've always thought about memory as sort of a cache, sort of sitting between, again, last level processor caches might be shared, and the disk, which is quite slow, or flash, which gets it above the disk. So now if I have two types of memory, one that's faster than the other, then I use, all we wanted you guys to do was say that you would use the faster one as a cache. What's going on out here? So if there's a lesson to be drawn from this, it's just don't get frightened off by the length of the question, right? I mean, this was a long question with a short answer that we were pretty generous about creating. So, any questions about this problem? How many people did this one? Maybe it's the people who came to class answered this question. I don't know. Where are the 106 people who didn't do it, right? All right. So, So Jinghao, is this the number of people who answered it or the number of people who used this answer? Answered it. So they got any credit for it at all. OK, that's interesting. All right. OK, so let's pop up the stack here, right? So let's see here. This one, I think, was the next least popular question. And this one, I don't know. I mean, this one had some code. This one looks long to me. It looks longer than the other one. I don't know why so many people tried to answer it. This question was not your finest hour. The median score was a 1. So it's not. I think a lot of people only got credit for identifying the multi-core performance problem and not any other credit, right? So let's walk through this one a little bit because I think this is interesting, and this is also a trick. It is kind of a trick. It's one of those things that once you see it, it looks obvious, but you might not have been able to come up with it on the spot. The idea is I'm looping through an array that I want to protect from multi-threaded access, and I'm looking for some free element. The key thing to identify here was that looking for elements doesn't involve writing anything. Actually locking an element, actually marking an element as used, requires the lock, right? That's when you're actually changing the data structure. But reading through the data structure does not. How many people can see an application of this technique potentially to assignment 3? What's that? Free pages? What about? Yeah, so what about alloc k pages, right? There's another case where you're going to be walking over a big data structure. You need to synchronize that data structure against multiple threads. But a lot of what you're doing is reading through the data structure to see if you can find an OK entry, right? So there are some potential applications of this to what you're working on. The code that you were given, and again, I'm going to zoom in a little bit. Let's see. Preview, view, zoom in. All right, so the code that you were given uses locks around the entire loop. So I grab a lock, I walk the entire array until I find an entry that's in use. What's a simple little trick I could do to make this a little bit less dumb if I really wanted to do it this way? What's a simple little improvement that would improve performance? Yeah. Okay, that's less simple than I was looking for, right? No, don't move the lock. Try something else. Without even changing the locking, what can I do to make this piece of code a little bit less terrible? Where is every thread starting to look? At 0. So where are entries going to be found first? Close to 0. So does it make sense to start every time at 0? So I could, one way to do it is to have a global variable where I store the last entry that I found and just have every time this called start from there. Another approach would be to just choose a random integer that's within the range of the array and start. In both cases, you have to make sure that you actually loop over the entire array. So there's a little bit of modular arithmetic that's required, but it's doable, right? So that would be one simple way to improve performance. But this was the question asked about locking, right? So there were people who talked about potentially, and someone just mentioned this, moving the lock inside of the for loop, right? What's potentially good about that? What will it allow to happen? Or why would you think, if I told you I was going to do that, why would you think potentially, initially, until we talked about it in more detail, that this was a good idea? Yeah, James.
Well, it looks like if you do that, then multiple threads can be looking at the array at the same time.
And they can. That's true. Actually, multiple threads can be in this loop at the same time. But have I actually solved a problem? Let's put it this way. Is the amount of time that a thread's going to hold the lock before it finds an entry going to change? No. Now here's another question. What potential problem does this cause? How could this make things worse? Yeah?
We're going to be having a ton of context switching.
Well, not just context switching, right? But like this function, this does something, right? Like this has code that it executes, right? Now moving this inside the array, I'm going to acquire and release that lock over and over and over, right? And so potentially, it'd be interesting to actually do the performance comparison. I've added quite a bit of overhead here, and I don't really, there isn't really a benefit, right? The amount of time the threads hold the lock. Now again, what's going to happen is rather than with the one big lock situation, what's going to happen is multiple threads are going to queue up at the lock, right? So essentially, the next thread that comes through here is going to hit this lock, and it's going to wait. It's going to wait until every thread, not necessarily every thread, depends on how you implement your locks, but certainly the thread inside the loop is going to run unimpeded while all the other threads sleep, and then the next thread's going to come all the way through, all the way through. If you move the lock inside the loop, yeah, you get this illusion that multiple threads are sort of inside of the array looking at the same time, but you're actually not helping them, right? You're just making them wait somewhere else, right? It's probably a little bit more efficient just to have them wait outside of the lock. So, what was the solution to this? So that the one favorite wrong answer was, according to Jinghao's very helpful feedback, was people who wanted to just move the lock inside the loop. Why can't I get to the next page? The correct solution, or the solution that we were after, again, exploits the fact that you don't need the lock to read the array. But, so the idea here is I can safely search the array without the lock. But what's the trick? What do I need to make sure I do? So again, I can walk through the array without holding the lock. I'm only performing reads. No problem. Clearly, when I mark the element as used, I need the lock. But what else do I need to do? Yeah?
I was going to say, if you use a global variable idea with the index, you find the index of 3, and then you execute the loop, and then you apply the lock, you use that global variable.
No, I wouldn't. I think that's dangerous. I think you'd have to synchronize that global variable. I wouldn't do it that way, right? This is the solution, right? So you can just look at what this does. Yeah, Damien.
Check it again, because even though you thought it was valid before and you
Right.
lock, someone else, you could be waiting at that lock and someone else changed it.
Right, exactly. So the idea is I can walk through the loop safely without holding the lock. But when I think I find something, I need to grab the lock. Now I have to grab the lock anyway because I need to grab it before I mark it as in use, right? I mean, clearly I'm making a modification to a shared data structure. That's not safe to do without a lock, right? I don't think anyone would disagree with that. The trick here is that I have to check the element again, right? Because what can happen? So let's say 2 threads enter this loop, right? 2 cores looking through this together, which is nice because they're both searching the array simultaneously. This is actually the worst case scenario. This isn't going to happen very often. But the 2 CPUs enter the loop. They're both inside the loop. Neither one has the lock, right? Let's say they both find element, I don't know, 10 is free at the same time. Then the problem is if they both acquire the lock and mark it as in use, then they're sharing the element. They don't want to share the element, right? They both need to produce a unique index for them to use to store their double rainbow, right? I hope people still get that reference because that's a funny video. I always watch it when I feel a little sad. It always makes me happy. So they definitely need the lock before they do the write. But what can happen is if they both, let's say they both find 10, now the point is the lock serializes them, right? So they've been looking in parallel. Now the lock forces them to operate in serial. One of them is going to win. It's going to get into the critical section first. It's going to find that the element is still marked as unused. It's going to mark it as used and exit. The next one's going to enter the critical section, which is now quite short, right? And only doesn't involve doing any searching, just involves doing some setting. And it's going to find that valid is 1, right? That this element is in use, and it's going to break out and keep searching, right? But that's really the worst case scenario, right? The worst case scenario is you have this collision on a lock. Most of the time, right, that won't happen. And you'll be able to search this array. Particularly, I would argue, if you do some randomization of the starting point, right? Because if I have an array and the 2 threads on different CPUs start from different places, the likelihood that they're going to find the same entry is pretty small, right? It sort of reduces to the case where there are only a few entries that are left in the array at all, and so they were both bound to find the same one because there just aren't very many choices. Yeah, Tom, do you have a question?
I was just going to ask, is it really even possible for them to actually fire at the same exact time?
Yeah, sure.
It does happen.
It can happen, right? If it can, it will, right? And it will, and the auto grader will do it. That should be your sort of, you guys know this by now, right? If there's sort of terrible behavior in your code, we will find it, right? Yeah, Doug.
So, if you did have the global variable, how would you care to check that you've gone the full way around the array? Or would you only care to go, like, let's say you didn't find it starting from your global variable till the end of the array. Would you then loop back, or would you kind of leave that for? No,
you always want to check the whole array, right? You know, and with it's actually a little more complicated than that, right? So this is a shared data structure. Let's say, so Doug's question is, if I start at a random point in the array, should I walk all the way to the bottom and then start back at the top and walk to where I started? Of course, right? Otherwise, I might choose the second to last element, right? And then I only have 2 elements that I'm going to search, right? So I don't want the probability of finding an element to depend on where I start. However, what's an additional complication in code like this that's actually in a shared data structure? Let's say this is quite occupied, but there's a lot of threads that are sort of banging on it. What could actually happen? I could walk all the way through the array, go back to where I started. So should I fail? Am I sure at that moment in time that there's no more space in the array? No, because it took me a while to do that, right? I might have had to acquire a lock a few times. Other stuff's happened. So I could potentially keep looping until I'm blue in the face, right? Like, I mean, at some point you should probably fail. And it might be reasonable to fail after 1 loop iteration. But it's not necessarily completely correct in the case that you want this to always find an element if an element exists, right? So that's a tough, let's put it this way, that's a tough property for this particular function to provide, given that this is a shared data structure. Yeah?
Don't values valid and fails have to be volatile?
Do they have to be volatile? No. No. Neither one of them, actually. Remember, I mean, the rule for it's never, here's the problem with volatile variables. First problem is nobody knows how to use them correctly, right? And the second problem is because no one knows how to use them correctly, no one can tell anyone else how to use them correctly, right? And that category of people includes me, right? But here's what I know about volatile variables. A volatile variable is usually used to indicate to the compiler that an assumption it makes about a variable is potentially wrong, right? Here, the compiler can see that the value of failed here depends on this other value, right? Which it probably won't assume it's going to know anything about, right? So the point is that you would only mark failed as volatile if you were worried that the compiler might think it knows more than you do and optimize out this check. But there's no way that's going to happen here, right? Because the value of failed clearly depends on the code flow, right? If you had a block of code where you said failed equals 0, and then if failed equals 0, do something, then you would need to mark that as volatile, right? If it wasn't just a bug, right? Because in that case, the compiler has no idea what you're doing. It's like, hey, you just set that to 0, then you checked it. I know what the value is, right? Here again, because the value depends on the code flow and the value of valid, right? Then the compiler won't make a mistake and optimize out that, right? It's normally safe to mark things as volatile, as you guys have probably found out, because your code is probably covered in volatile variables. And you don't know why you marked them volatile, but it just seemed like it was something to try. And it's not, as far as I know, it's a good question. I mean, it probably can create problems in certain sort of corner cases, but in general, it's just going to make your code a little bit slower. It's going to force the compiler to do some more checks than it might not normally do. Right? Good question. Yeah.
If things could go back to being empty, like valid to be put back to 0 after
Sure.
that one, would you have to lock around the entire array so it doesn't change behind your back?
No, I mean, this is assuming that valid can go back to being 0, right? The code that clears this, right? So this is saver, right? When I'm ready to retrieve my double rainbow and run off with it, that piece of code which wasn't shown would have to lock the element as well, right? That's simpler because you're assuming I'm giving you an index, and so I don't have to do a loop in that code at all, right? I need to know exactly which index double rainbow I want to remove from the array, right? But then I can just lock that element, mark valid to 0, and unlock it, and I'm done. Right. That's a good question. Any other questions about this? This is why I don't love putting coding questions on exams. I always feel like they're kind of like, again, until you see the trick to it, it's hard to do. So, all right, let's go.
I have a question
Yeah.
from like an operational standpoint. Why do we bother returning failed? Because, oh wait, never mind, sorry. Wow.
I like that question. Okay.
Never mind.
Come on. Let's see, zoom to fit. There we go. Okay, so let's look at, so that was 72. This one was, well, that was very popular. It was easy. 94, 44, okay, 94, right? I don't know why this was hard. I think it's because I asked for 3. Most people got fork and exec. Most people did not apparently remember one of mmap or sbreak. I think if I had asked this question now, the median would have been a 5 because people now know about sbreak. Read and write. I don't know why apparently they were popular wrong answers. I don't really understand that. Maybe just because they're system calls and hey, why not, you know? But anyway, any questions about this question? I thought this was pretty straightforward. I think it was just sbreak and mmap that tripped people up. Mmap, yeah, it's a little esoteric. Sbreak, though, is kind of important. All right. Feel free to slow me down if you want to talk more about some of these. Let's see. Yeah, this one was easy, the illusions one. So, you know, most people got one of these. We had talked about a bunch. There's probably some others here. Jinghao, were there other answers that aren't in the solution? Yeah. I guess Zihei graded this one, so I don't know. Yeah. But I'm guessing that people put other things. 5 was the median score. This question was too easy. Thankfully, though, people realized it was easy and did it, unlike the other one where people didn't realize it was easy. And then I think, so the scheduler one, I guess this question was also easy. People forgot what RSDL stood for. I actually hadn't realized this myself, to be honest with you. I knew it stood for rotating staircase deadline, but I didn't realize how. But, you know, we're playing some games with the L in deadline to get that to work. I don't know why he wanted to call it RSDL. was trying to remember. There's some sort of like drinking club in Australia that has an acronym that's similar to that. So maybe that's where it came from. But anyway, apparently RSD was not acceptable. But yeah, so that was this question. Yeah, Tom. RSDS? I think that sounds so much like R2D2. So, you don't want the Star Wars reference there. RSDS. All right. So we did this one. Oh, and then the memory one. Yeah, a lot of people did this one. It wasn't that tricky. This was actually funny because I didn't even do this on purpose. I'm pretty sure that I just used a random number generator to come up with these, but it fooled you. It spit out two that looked very similar to each other. So a lot of people apparently used 4758 as the virtual page number for this fetch because it's actually, let me zoom in, it's in there. Yeah, 4758 is in there, but that actually is not the page number for that page. The page number is 475, which was not in the page table. And then, what was the other issue? Oh yeah, people missed the permissions on 5. So that was read and execute, and there was a store, meaning that would generate a TLB read-only exception. So, any other questions about this question? Any other questions about these questions? Okay, good. Sort of going right on time. So we have 10 minutes, 20 minutes to talk about the other two questions. All right, so let's talk about these. Okay. So there were two long answer, medium answer questions. So if you guys haven't looked at the previous final exams, the final exam will consist of a the final exam is basically the midterm plus a series of longer answer questions, right? And normally for the longer, I really enjoy writing the final because the longer answer questions give me a chance to go out and find, it gets a little bit harder every year, but I get to go out and find sort of novel research operating systems that have cool properties and then ask you guys to sort of pontificate about how they might work or whatever. You guys have, if you looked at the last few exams, you've seen that. But there's some interesting sort of bits of practice here that people miss. So we'll talk about the answers to these, but I also wanted to point out some problems people seem to have with approaching these problems, right? So at least according to Jinghao, right, who is pretty smart, he didn't think these questions were that hard. However, but the median scores were not great, right? The split between these questions, I think, was pretty good. I don't think one of them was substantially harder than the other. It looks like a good, I get worried when it's like 145 people did one and 5 did the other, right? And the 5 that did the wrong one got like a 2 or something. So that's not what happened. Scores were pretty similar. But one thing that apparently a lot of people failed to do was just follow the outline of the solution that was embedded in the question, right? So for example, the first question says, first, do this. Continue by doing that. You will want to consider this, this, and this, right? Second, consider. You will want to think about, right? This one, first, explain how and why. What information? Second. So I guess, Jinghao's impression was that some people hadn't read this part of the question, right? Just unfortunate because this is a template for your answer, right? Now you're welcome to be like creative, right? And come up with like a brilliant, I don't know, maybe like some sort of inductive reasoning based approach to laying out your answer in a way that, but keep in mind that these guys are reading like 75 of these questions, right? So if you follow like the playbook, then it's probably easier for them to digest, right? So that's one suggestion that you guys should apply to the final, because the final exam questions will have similar things like this, right? I want to give you guys, this is sort of intended to give you guys hints about how to approach the problem, but it also ends up providing a little bit of a scaffolding for putting your answer on, right? All right, so yeah. And then it's a little bit more feedback on these. So the interactivity detection problem, the feedback we got, to walk over the solution if people want to, was that the feedback we got was that people were, had absorbed some of the stuff we talked about in class about the challenges of identifying interactive tasks, and seemed to be able to regurgitate some of the approaches that we talked about in class to identifying interactive tasks. What you guys weren't so good at doing was actually mapping this to the unique features of smartphones, right? So we got a lot of answers that seemed like they were pretty much, they answers to a question asked about interactivity detection in general, rather than an answer to the specific question about interactivity on smartphones, right? So answers that didn't use the sensors, didn't think about the different usage patterns, didn't sort of consider the always-on nature of smartphones, didn't talk about background tasks, et cetera, right? So the scores for this were divided into 2 points. My guess is that's why the median is pretty close to 10, because a lot of people got the first 10 points. The second 10 points were probably harder to come by. We didn't break it down that way. But again, I mean, the things we wanted you guys to notice is smartphones in many ways are, well, the first thing is smartphones are always on devices, right? So on a lot of other types of computers, I mean, when the machine's on, there's probably somebody in front, right? With the smartphone, the machine's on all the time, and yet the number of hours a day that people actually use them is pretty small, right? Most of the time they're powered off, the screen's dark. They're still doing some stuff, right? They still do a lot of stuff in the background, but they don't necessarily, there's not necessarily someone whose eyeballs are in front of the device waiting for something to happen, right? I mean, how many people think they would notice if the notification that they have a new Snapchat or whatever came in like a couple of seconds too late, right? You're not going to see that, right? So that's a very different type of timing expectation driven by some of these background things. It's a lot more akin to some of the long-running background tasks that we talked about in class. And then the other thing I think that's really interesting about smartphones is that the displays really end up driving a lot of the way that they're used, right? I mean, I don't know. I mean, maybe I'm just not a power user, but my impression is people don't tend to do like 10 things at once with their phone, right? Because they may be switching back and forth between things rapidly, but it's not like a windowing environment where you have like 6 or 7 windows open and there's a lot of different things that could be going on. That makes the operating system job harder, right? Because now it actually has to like track your eyeballs, right? And I think people have actually tried to do this when you look at things like laptops. Which part of the display you're actually looking at, right? So I can figure out if it's see, there's sometimes when you care when the background notification comes in, right? So that was the other thing we wanted you guys, one of the things you guys could have noticed. There's also sensors on the device that might help, what type of orientation is the device in, even something as simple as if the screen is on and off. I mean, that's kind of an obvious one, right? And we tried to be generous about giving out feedback for people who incorporated any of these types of ideas. Any questions about the answer to this problem? This is probably pretty, of the two medium answer questions, this is probably the one that I would look at as sort of a model for the type of long answer questions you'll find on the final, right? The jumbo pages question was just a little bit of kind of a trick, right? It's like, whatever, okay. I mean, it was nice to be able to see people identify the design trade-offs, but this is a more open-ended question of the type that, we want to see you guys take the design principles that we've taught you in class and apply them to new problems, right? I mean, that's what you guys are going to do in the future. You're not going to write more OS 161 code, right? No one cares if you can do that, right? But if you can, whatever, man. You go hack on Windows, and then you'll be like, please, I really want to go back to working on assignment 3. It was so nice and simple. It probably applies to every piece of software you guys will develop throughout your software careers. You guys will be wishing you could go back into these assignments. Yeah.
For the questions on the final, will you need some sort of familiarity with what they're talking about? I don't know anything about that.
Yeah, so we try to provide enough information in the question, right? So I think if you go back and sometimes that involves providing a little bit of context, right? So there are hints about these devices that were embedded in the question. I would argue, and I know so much about these that it's difficult for me to really judge this fairly, but I would argue that probably there was enough information in that question for you to craft a reasonable answer. And certainly for the exam, we'll make sure that's the case, right? So if we are asking you about some new property of a system that we want you to think about, design trade-offs or how you implement it, we'll tell you as much about it as you need to know. Yeah, James.
Will there be any choice for the long answer, like any you can choose from on the final?
It's usually like 3 choose 2, I think. There's usually 1 medium answer question, and then there's usually 3 long answer questions. In the past couple years, you guys may have heard this, I have been fond of luring people to do the course evaluation form by releasing questions for the exam early, which I will do again this year once they post the form. Right. So I think last year the deal was if you guys got to 90% participation, I would release one short, who cares, 1 medium and 1 long answer question. And there's different levels, because the feedback is really useful to us. So I really want you guys to do the form. I've discovered if I don't give carrots, no one does the form. Right? I mean, the other classes, it's like, they're trying to draw conclusions based on a 20% completion rate, right? Last year we had like 93, right? So that was pretty awesome, So yeah, but once I get, actually, have you guys gotten emails about course evaluation forms yet? Okay. Usually they tell us when this happens, and then I'll tell you. But the normal detail, I think last year was 70% gets you the short answer, 80% gets you the medium answer, and 90% gets you a long answer. Right. So you have to encourage, and this is a bigger class, so you guys may have more shirkers that you need to pound down. What's that? Yeah, I always factor out the people who have resigned. Yeah. I mean, define dropout, right? I know about some dropouts, other ones, people don't show up for the final. Those I can't factor out. So that's why we only do 90. It really should be like 99.9 or something, because you guys should do the form too. It's helpful for us. All right, so let's talk about the jumbo pages. So let's see what so I was really happy people managed to identify spatial locality and reasons why jumbo pages would improve performance. There were some people who got some partial credit for also pointing out that the kernel paging related data structures would be smaller. There's fewer pages. Page tables are smaller. That's kind of cool. It's not clear to me though that, well, anyway, in a real built system, I wonder how that would work out, because you actually now have 2 different sizes of pages, and so there are probably some other data structures that might be a little more complicated and maybe a little bit bigger, but I'm not sure. So I like this. The people who answered the question found a problem that the solution had missed, and I think I thought about this when I was writing the question, and then just blanked when I was writing the answer. So I'll fix it at some point. But internal fragmentation is obviously an issue, right? I have to do big allocations. I don't know how well they're being used. The I/O bandwidth of moving things back and forth to disk is something that the solution does mention, right? But that was actually pointed out less frequently by people who answered the question, and it's probably fair, right? The internal fragmentation is probably a bigger issue. I guess the problem with the implementation, the big stumbling block was people forgot that if I'm actually going to play games in the TOB, I need a TOB that lets me play games, right? So if I'm going to change how entries are loaded into TOB, I need to be able to do that in software, right? If I have a hardware managed TOB that only maps page fault to 4K page, then there's no way to implement this, or no way that I know of, right? You're sort of stuck. I mean, never mind. There's probably some disgusting things you could do, but I think they would have their own sort of issues. All right. Any questions about this problem? This one was a little more mechanical, right? I mean, this required you guys just understand a little bit more. But the design trade-offs as far as doing this were really what we were more interested in determining. All right. So it's 40 after. I'm done with what I wanted to do today. If you guys have more questions about the exam, feel free to stick around. Otherwise, on Wednesday, we will return to OS performance. It's the happy part of the performance story, about how to get things to actually work. So I'll see you guys then.